So what you're going to see is a 2-column proof is really a model or a tool that can help you with a paragraph proof. So not that all of you may choose to go on in your future careers into something with math. I obviously went into something with math, so classes in college, I had classes that were just on writing proofs. And when you have a mathematical proof, a proof is really written, it kind of looks like a math paragraph or essay. It's written as a paragraph. So the 2-column proofs that we use are really like an organizational tool for a paragraph proof. So you're going to see when you go through example 1, I have in the first step to organize your proof using the 2-column proofs we've been creating. Paragraph proofs. So as you can imagine, it's kind of like taking your 2-column proof and putting it into sentences to write it as a paragraph. So it's writing sentences to explain why a conclusion is true. But like I said, it's basically taking your 2-column proof and each line that you have is a sentence. So that's why we're going to set up a 2-column proof to help us organize our thoughts for this. So in example 1, and I have a picture there for you of a segment. So it says S is the midpoint of QP, T is the midpoint of PR, and P is the midpoint of ST. Write a paragraph proof to show that QS is equal to TR. Okay, so we're trying to show that these two pieces are equal. I'm not going to mark that because I don't know that they're equal. I'm trying to prove that. So, organizing our proof. This is my thought process working through it. I'm going back to what I'm given. So I'm not actually going to write the given out. I'm going to write it this way to help organize it. So first thing I'm given that S is, I'm going to abbreviate midpoint here. S is the midpoint of QP. Okay, what does this information tell me? If I look at my segment, if S is the midpoint of QP, what do I know? What conclusion can I make? QS and SP, those segments are congruent. Okay, so I'm going to say QS is congruent to SP. And what's the reason for that? Midpoint theorem. So I'll put by midpoint, I'm abbreviating again, midpoint theorem. Okay, I'm organizing my thoughts. So here's kind of my reason. And then when I put by, here's my statement, and here's my reason. Okay, now I'm going to look at what else I'm given. T is the midpoint of PR. So again, looking at my picture, if T is the midpoint of PR, what do I know? So PT and TR are congruent to each other. And what reason is that? How do I know that? Same reason, midpoint theorem. Okay, then I'm given P is the midpoint of ST. So P here is the midpoint of ST. Therefore, what do I know? If P is the midpoint of ST, okay? Yes, SP is congruent to PT. That would be by the same reason. So notice how I labeled my picture. So really, that means that SP here, I could put 2 tick marks because I know it's congruent to PT, meaning this one also has 2. So by reasoning, these are all congruent to each other. Those 4 smaller segments are all congruent to each other. However, I'm trying to now get to a point where I can say that QS, so this segment, is equal to TR. So using reasoning with my picture, I know that they're the same, but I now have to use those properties to show why. And again, this is like my 2-column proof. So right now where I have these this by written here, this is like where you would have your line. And so here are my statements, here are my reasons. So I know these things are true by midpoint theorem. So now I have to look at these statements and figure out a way to get to this conclusion. So since I want to get to QS equals TR, right now when I look at this, I see QS right here. And I see TR right here. That's where I want to get to eventually. But right now I know QS is congruent to SP. I also know SP is congruent to PT. So I can't jump straight to saying this, but if I know QS is congruent to SP and SP is congruent to PT, I can say QS is congruent to PT. And what reason did I just use? That is the transitive property. Okay? Then, because again, I'm trying to get to TR. Now, if I know QS is congruent to PT, I also have PT in this line. PT is congruent to TR. So here's QS, here's TR. They are both congruent to PT. So if QS is congruent to PT and PT is congruent to TR, QS is also congruent to TR. By what reason? Okay. Substitution, or I use transitive again. But if you put substitution, I would accept that. I'm going to put transitive because I like us to recognize when transitive is used. Okay, we're almost there. Notationally, I did not prove what I wanted. I didn't want segment QS is congruent to segment TR. I wanted just QS, the measure, is equal to TR. So what says if segments are congruent, their measures are equal? Definition of congruent segments. Okay, I'm just going to abbreviate that here, segments. Okay, there's our 2-column proof that we now need to put into sentences to create a paragraph. Okay. So starting out, here's how I would write this. And I am going to include this given information, okay? So I'll say, I'll start out, I'll say since, I'm going to state this line first. So since S is the midpoint, so now I'm not abbreviating things because I'm actually writing out a paragraph. So since S is the midpoint of segment QP, comma, segment QS is congruent to segment SP by the midpoint theorem. Okay, I don't want to write too fast. I just wrote the first line I had as a sentence. So since S is the midpoint of QP, because I have to say how I know this line is true, since S is the midpoint of QP, QS is congruent to SP by the midpoint theorem. And now I'm going to say basically the same sentence for the next two lines as well. So I can say, if I don't want to use since every time, I could just start with T is the midpoint of PR. And then I'll put so PT is congruent to TR by the midpoint theorem. And then I'll say also P is the midpoint of ST. So SP is congruent to PT by the midpoint theorem. Okay, so just stating those first three lines I had above, putting them into a sentence. Okay, from here then, I can say, and again, when you're actually writing these out, the wording, I'm just looking to see, for example, like you have your statements and your reason. So I have my statement and my reason in each sentence. Statement, reason. Statement, reason. So then my next sentence, I'm actually going to start out by saying this. I'll say by the transitive property QS is congruent to PT. Okay, so I stated my reason first, but by the transitive property, our next line we had said QS was congruent to PT. And then I can say also by the transitive property. QS is congruent to TR. So reason, statement. And then I've now gotten to my last line. So I can say, therefore, by the definition of congruent segments, QS is equal to TR. So reason, statement. Okay, so organizing your thoughts, coming up with your statements, reasons, using what you're given. So reason through it first, and then you're putting all of that into sentences. Not all of the ones have this many steps. This one had a lot of given information. Okay, questions on this example? Okay, am I okay to go to the second one? Second one is much shorter, by the way. They're not all, like I said, they're not all this many sentences. Okay, example 2. This is given that, look above the AB. What does that symbol mean? Ray. So it says, given that ray AB is the angle bisector of angle CAD, write a paragraph proof to show that angle CAB is congruent to angle DAB. There's no picture. That's going to be my first step, is to draw this. So I have angle CAD. Okay, and make sure when you're labeling this, so the middle letter, the A, that's the vertex. And then I have C on one side and D on the other, or the two rays. And I am given that ray AB is the angle bisector. First of all, what is that? What is an angle bisector? Okay. It cuts the angle in half. So here's A, and I have a ray with B that's cutting my angle in half. If you look, I have mine out. If you were to look at your properties packet, I just have to find it. All right, guys, I need your attention up here, please. Definition of bisect is to divide something into two congruent parts. You divide it in half, but you're dividing it into two congruent parts. So by definition, this ray is dividing this angle into two congruent angles. If I'm trying to prove CAB is congruent to DAB, what proves it is the definition of what an angle bisector is. So this one's super short, it's one step. If ray AB is an angle bisector, of course, these two angles are congruent. I just now have to state that. So there's really not a two-column proof to set up with this one, because just by definition, this is true. So I'm going to say, here's how I'll word it. By the definition of, oops, not an angle bisector. So by the definition of an angle bisector, I'm going to say ray AB divides angle CAD into two congruent angles. So therefore, angle CAB is congruent to angle DAB. That's really all I have to say. It's by the definition of an angle bisector. This is what that means, and therefore the two angles would be congruent. Okay, so a paragraph proof doesn't mean you're going to have, 5+ sentences necessarily. It just means you're reasoning through it and writing it in sentences, whether that's a couple sentences or more.